All right, we are solving systems with substitution when we need to isolate a variable. Now, if you need to review the steps for solving systems with substitution, you can review yesterday's video. So the first step is to solve for one of the variables. Now, here it doesn't matter which variable we solve for. We can solve for x or y in either of our equations, but I recommend always solving for a variable with a coefficient of either 1 or -1. And so here we have this imaginary 1 in front of our y. So I would recommend solving for y. And the reason is because if, for example, we were solving for x, I would have to divide by 2 all the way across this equation, and I would end up getting fractions. This is fine, but it takes a little longer. It's a little more challenging, and we're more likely to make mistakes. So if we can avoid having to work with fractions, it's much easier to work with whole numbers. So we want to solve for those that have a coefficient of 1 or -1. So let's rewrite our original equation. And again, we want to solve for y. So that means we want to isolate y. So I'm going to subtract 2x from each side. And I'm left with y equals -2x plus 4. Remember, these are not like terms, so we have to keep them as two separate terms. We can't combine them. All right, so now that we've solved for y, our next step is to take y and plug it into our second equation. So our second equation is 2x plus 2y equals 2. And I'm just going to go ahead and I'm going to substitute this for y. So we have 2x plus 2 times y, which is -2x plus 4. And then I'm going to copy down the rest of my equation. All right, the next step is to use the distributive property. So I'm multiplying all the way across this expression. So this is 2x plus 2 times -2x, which is -4x. 2 times 4 is 8, and then I copy down the rest of my equation. Now, and we don't actually need this addition sign here. So now our next step is to combine like terms. So we're going to combine 2x minus 4x, which is -2x, and then we copy down the rest of our equation. Now we're isolating for y, which means we want to start by getting, we're isolating for x, which means we want to start by getting -2x all by itself. So we're subtracting 8 on both sides, and we're left with -2x equals -6. And we're isolating for x. So divide each side by -2. X equals 3. Remember, a negative divided by a negative is a positive. So now we've solved for x, and we want to go ahead and now find the value for y. So to do that, we're going to take the value for x and plug it back into one of our original equations. It doesn't matter which one. You can choose whichever one you want, and I'm going to choose the first one. So this is 2x plus y equals 4. Okay, I'm just copying down that original equation. And then we're taking our value for x and we're plugging it into our original equation. So 2 times 3 plus y equals 4. We multiply 2 times 3, which is 6. And I want to isolate positive y. So I subtract 6 from each side. And we get y equals -2. And so my final step is to write my answer as an ordered pair. So this will be 3, -2. Okay, and that's my solution. Okay, so on to our next example. Again, we want to start by solving for one of our variables. It doesn't matter which variable or which equation, but I recommend solving for a variable with a coefficient of 1 or -1. So here we have our imaginary -1 in front of x. So I'm going to go ahead and solve for x in my first equation. So let's start by just rewriting the first equation. And we want to isolate for x. So I subtract 3y from each side. My 3y's cancel out, and I'm left with -x equals -3y plus 3. All right, and I want to be left with just x, not -x, positive x. So I'm going to divide by -1 all the way across my equation. So I'm left with x equals 3y minus 3. All right, so now that I've solved for my variable, I'm going to go ahead and plug the expression for x into my second equation. So I'm just going to rewrite my second equation down below. So this is 2x plus 3y equals 3. And I'm just substituting this expression in for x. So this is 2 times x, which is 3y minus 3. And then we're rewriting the rest of our equation. So plus 3y equals 3. My next step is to distribute all the way across my expression. So 2 times 3y is 6y. 2 times -3 is -6. And then we copy down the rest of our equation. My next step is to combine like terms. So here 6y and 3y are like terms. So 9y minus 6 equals 3. So now we want to isolate y. So I add 6 to each side. Oh, there we go. I add 6 to each side. This is 9y equals 9. And I divide by 9 on each side. Our 9's cancel out, and I'm left with y equals 1. Okay, so now that I've found the value for y, I'm going to plug this back into one of my original equations. It doesn't matter which equation, so I'm going to pick the first one. So let's just rewrite our first equation, -x plus 3y equals 3. And I'm going to take my value for y and just plug it into my original equation. So I'm just substituting it. So this is -x plus 3 times 1 equals 3. 3 times 1 is 3. And I want to isolate x. So I subtract 3 from both sides. My 3's cancel out. -x equals 0. And if I divide both sides by -1, I get that x equals 0. All right, so the solution to my system is 0, 1.